Hello. Hi, this is Kanan from Futurum Corporate Finance. Uh, I want to share something with you. I believe that this the topic that I'm going to discuss with you is quite relevant for those that get involved in the project evaluation, and also if you have financing from the lending institution. I'm talking about the annuity. Some of you probably is already quite familiar with the annuity because we are quite often using that during the evaluation of the project opportunities. For example, if the project generate the cash flow in the equal amount of cash flow at a fixed regular interval. And there's also a case where in the like a mortgage or car financing or motorcycle financing, and also in the bonds where you are see that the amount of that you paid to the lending institution is make on the equal or fixed amount of money every, for example, every month or every quarter or every certain period of time. And that payment will be will be ending on the specified time period. This is what I'm talk about the annuity. So before we if you can look at my computer screen, you can see I put the subject of this video: common error in calculating annuity. Probably you're a bit surprised why I need to bring up this issue. I will explain that more during this screen recording. Okay, so if you look at my computer screen, I put here what I call like a timeline. You can see that I put here 1, 2 until n. This is timeline. So during the project evaluation, or if you want to evaluate the financing, you need to have at least two things to be very clear. First is when the cash flow will be generated by the project opportunities or project alternative. Here I put C. So it's an abbreviation for the cash flow. And because it's an annuity, its cash flow will be in the same amount of money. So if you look at the first year, second year, and third year, it's all start with C, 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 C. So the amount is the same. So for example, here is 100, here is 100, and this is 100 until the end of the project or the end of your financing period. And also, the other things that you need to be very quite clear is about the timing of the cash flow. We need to know when the cash flow will be coming to our bank, and plus for example, on the other side, if there's a borrowing, you need to know when you're going to pay to the bank, for example. So and if you look at the interval from 0, it means today, to 1 and 2 and 3 and until n, this is all in the same fixed regular interval. So 1 year means 12 months, so you have here 12 months, and then you move here to second year, it's a 12 month, and then another 12 months, and until another 12 months. So this is what I mean with the annuity. And the other side, of course, we're going to talk about the present value. If you look at the other the other formula here that I put below this timeline is PV means present value. Yeah, this is a very common technique where it's quite necessary to do that, because as we know that in the timeline, all this cash flow happens on the different point of time, and in order to be able to compare or combine all this cash flow at the same point of time, in this case 0 or today, we need to apply the present value technique. And definitely all the present value technique will require what we call like a discount rate. In this case, I put R. R means rate, it's abbreviation for rate, and then it means for the discount rate. So the first year you just divide it with 1 plus R, and in the second year you just divide it by 1 plus R. We have here 2 because this is the second year, and the third, and so on until N. So why we need, of course, first we have to answer why we need the present value. Yeah, because I already said that the present value is enable us to compare or combine the values of the cash flows at the same point of time. And of course, this is a very basic knowledge in the corporate finance, where we know that the dollar today or rupiah today, $1 or 1 rupiah today is it is not the same with the dollar or 1 rupiah in 1 year, for example, from now. So it is very quite common sense and finance sense, because if you have a money now, it is more valuable than having the same amount of money in the future or in sometime in the future, because we know that in this modern world, you can earn you can put your money, for example, to the bank, and then you earn the interest on that on that money. So all right, and then of course, in the present value, don't forget that this is all annuity. The first annuity will coming at or you have to pay it at the end of the first year. So it doesn't happen in the today, but it happens in the end of the first year or first period. So whatever present value technique that you apply, that will be bring back or move back to the today value. Okay, so hopefully it's quite clear for you for what I mean with the annuity. And the other side is we need to there's a one quite because this is a very long formula. Of course, if you look at this is an N period here, it could be like a 5 years, 7 years, 10 years, and of course it's quite not comfortable. If you have quite awkward for you if you have to calculate this one by one. So there's one astronomer. It names is if I'm not wrong, is Edwin Halley. He create one short formula that we can apply and can get the same result for the annuity. And I show here the present value of the annuity. I think you can see that. And then basically this is for the say plus say times 1 divided by R, and then you times 1 minus 1 divided by 1 plus R, and then you have N here. This is the same period with your specified time period. And this this short formula is quite handy because you can apply that. This short formula is quite old because is found or not found is astronomer Edmund Halley give us this formula back in 1761. So it's quite old formula. Hopefully you get familiar with this formula. Of course, in the Excel, they help us a lot to calculate this present value of the annuity. We're going to also touch on the Excel formula. Okay. So the issue of this video is there's some misunderstanding. You know, it's some confusing for probably for some student or people who get involved in the corporate finance, because if you look at this C, this is for the cash flow, is a fixed amount of money for first year, second year, and third year, and so on. Then the R, the big question is this is the R, is this the same R? Meaning that you have to apply the same R, for example, here 10%, in the second year is 10%, in the third year 10% and all. But we know in the modern world, in this finance world, we know that all the discount rate is not the same. It really depends on your horizon or your investment horizon. So each investment have their own what they call is a maturity, and this R, or is basically is a return. It will be vary by the maturity. Of course, I bring it to the website of the EBPA. you can type to the Google and then you type ebpa.co.id. I give you a very simple example. This is Indonesian bond pricing agency. So they give us every day how much is the rate for the, for example, here we have Indonesian government bonds. You can look at it here, Indonesian government bonds. It's called IGB here. And then the yield curve by maturity, or usually it's called or known as a term structure of interest, by maturity is not the same. Okay, I bring you, if you go on the right hand of your of my computer screen, you can see one term structure of interest by maturity. Here you have IGS, this is Indonesian government, and then you have triple A, and then double A, and then A, and then triple B. This is for the Indonesian corporate bonds spread. BPS means basis points. Okay, but I'm going to use the Indonesian government bonds for the reference to give you the example of the this issue. Okay, if you go to the left side of this computer screen, you can see the daily MTM price and yield. So I will click that. Okay, that will bring us to the Indonesian government bonds yield curve. So this is the uptrend curve. Yeah, it's quite normal, but of course in theory you can have a flat yield curve and also the downtrend yield curve. But here is the uptrend curve, meaning that the longer of your investment or the maturity of your bond of the government bonds, in this case is Indonesian government bonds, the interest required by the market is higher. So for example, for five years you have here almost 8%. Yeah, here. Now I think it's as you know that for Indonesian SBI, Certificate Bank Indonesia, is 7.5%. So I think for 8%, more than 7.5% is quite normal. So there's a spread that risk premium required by the market player. So 5 year here, you can see it's a 7.9424%. Yesterday it's a 7.9479%. And if you move along the longer maturity, for example, you move from 5 to 6 or 7 or 8 or 9, you can see that trend is up. So 6 years, 1 year after 5 years, people, the market player asks 8.0058%, and if you move to 10%, you got 8.3150%. So here the longest is 30 years. And the market required 8.9558%. Okay, so we know that the cash flow that happens or generated, earned in the first year, or the installment that you're going to pay in the first year, here is a 6.5970. And then in the second year, you have 7.5360. So this is all, the return is not the same. So if you go back to the Excel file, then you have R here, because you can also put like a R1 or R2. Yeah, but the formula here we gave you is only have one R, so it's implicitly suggests that we need to use only one discount rate or one rate of return. But this is a bit problematic, because if you go back to this Indonesian government bond yield curve, we do know that in the market, the interest rate for the first year and second year and third year and fourth year, it is not the same. So it's quite conflicting. Some people try to push to use one rate. Okay, I'm going to show you how to convert from the different interest rate here. To have one interest rate or discount rate that we can use in the annuity formula. Okay, hopefully you are following me. So I will put here the first year. So year 1, year 2, year 3, year 4, and year 5. For example, the investment opportunities or the your car loan installment is 5 years terms. Okay, I go back to here. The first year is 7.9570. The second year is 7.5360, and the third year is 7.7715, and then 7.8761, and then you have 794 for 24. So it's a 5 years, 79424. Okay, I will put that to the Excel. The interest rate you have here 6.9570, and then you have 7.5660. Okay, let me take a look again. Yes, 7.5360. Okay. Okay, and then in the third year you have 7.7715, and then you have 7.8761 or 7.8761, and then you have 7.9424. Okay, so for example, you have the annuity is for example 1,000. Okay, I put $1,000. Okay, right. And how to compute the present value? Okay, if you go back to this formula, I will use the first formula so that you can follow me. So it's a one. So I put here the first year, year 1. Year 1, year 2, year 3, year 4, and then year 5, and then okay, you have 1,000 here, and then I just copy here, so, and drag it. Right, and then okay, and then I need to put 1, 2, 3, 4, 5. Okay, and then your discount rate will be, the first year will be this one, the second year will be this one, the third year will be this one, fourth year will be this one, and the 5 year will be this one. Okay, and then your present value interest factor in the first year, that should be 1 plus percentage 1. Okay, and the second year plus 2. And the third year and the fourth year okay, and the fifth year Okay. Just have to fix this. Okay. So, okay. So all you need is you just apply. You divide it by 1000 by this one, and then this is your present value. Okay, I just copy to the right, and then your total PV is, your total PV will be sum from here. Okay, so you got 4,019 dollar. Okay. Okay. So I just put the color here, and I bold it. Okay, save. Okay, there's a misunderstanding, a bit confusing in the market where if you look at this, if you go back to this short formula, which R that you need to use, you know, because this R is a single R, single interest rate, single discount rate. So some people just jump to the 5-year discount rate because they say that this project is for 5 years, so the discount rate should be 5 years. Instead of knowing that it's first year and second year and third and fourth year is a different interest rate. Okay, so this is the common error that people make. They just use one single discount rate. In this case is the 5th year. So they just move to the 5th year discount rate. Okay, and then they apply to this short formula. Okay, we're going to use that. The C is 1000. Okay, R or the discount rate is the 5th year. Okay, let's see whether, and then they're going to calculate PV is 1000. Oh, the period is 5 years. Okay. Okay, the PV will be C times 1 divided by discount rate times 1 minus 1 divided by 1 plus discount rate 5 years. Okay, let's see what's going on. Divided by 1. Okay, times this is minus plus. Okay, let me see what's y. Oh, this one I need percentage. Okay, so 35% times 1 minus 1 minus 1 divided by 1, 33%, 34. Why doesn't work? Okay, let me see. Times 100. Okay, let me see. Let me fix the formula. Okay, 32 times 1 divided by key. Okay. All right. Okay. So you can see that. Okay, let me put here black bold. So you can see easily that this result is not the same with this result. Okay, can you see that? So the short formula that we apply here, it doesn't give us the same result. Why? Yeah, because this is the one that we use here, the discount rate here is not right. We just use one single rate, and this one single rate, this is not correct, the one that we use, though the investment horizon is 5 years. So we need to find one single rate that we can use in this short formula for the present value of the annuity. I'm going to show you how to find that single formula. Okay, hopefully you follow me. That's not really difficult. We can use the Excel formula. Hopefully you are quite familiar with the PMT formula. I will put rate here, and then the PV, and then PMT, and then the face value, the future value. Okay, and then N pair is 5 years. Rate is, this is the one that we're going to find. PV is we need to put here. Okay, and then the PMT is 1,000 or 1,000. Okay, and then the future value is 0. And then we can apply the rate formula. Rate is ampere, PMT, PV, and then 0. And you can see that this gives us the formula 7.75%. Okay, let me highlight that. And then I put bold. Oh, sorry. Should be black, I think. Okay. And then I give a yellow background, so it's easier for you to. So this is the single rate that we need to apply when we use this formula. Okay. So the R, the revised one, or the correct one, discount rate is okay. Okay, so I repeat the formula is C. You just follow this formula. C times 1 minus 1 divided by this formula, this percentage times, times 1 minus 1 divided by 1 plus this 5 or 5 here, and then you got C. It is the same. Okay, so okay, so hopefully you going to understand this video where I show you that how to find one single rate that you can use in the short formula for to get the present value of the annuity. So we need really very careful when we do our when we are doing our investment or project evaluation. We need to think about which discount rate that we have to use. So if you use the short formula, then you need to be very careful. Don't just jump to the interest rate of the for example, in this case is 5 years, but we need to get one single rate that can be used by using the Excel formula PMT. In this case, I use a rate to get that. Okay, hopefully you understand this video. If you are not quite clear, you can send me email. My email is in the website, and I will get time to reply your email. Okay, thank you, bye bye, cheers.